Yeah. Hello everyone. My name is Disha Kansara and my SEP ID is 60001198003. And today I'm going to explain the inverting and non-inverting comparator, zero crossing detector, time maker circuit, and the sample in hold circuit, which is designed in LT Spice. So first of all, let's see the circuit of theory of the inverting comparator. So yeah, this is the first circuit of the inverting comparator, which is where the comparator which compare the analog voltage level with the another analog voltage level. So where the vref and the uh, uh, produces an output signal based on the voltage comparison, and the for the non the inverting comparator, the the first circuit, where the opposite of the positive configuration, the reference voltage is connected to the non-inverting input of the operational amplifier, and the input signal is connected to the inverting input. So where the Vin is less than Vref, the op-amp comparators output will saturate and towards the positively supply VCC, and reverse, when the Vin is greater, then the Vref, the output comparator, op-amp comparator output will change the state, saturate towards the negative supply of the 0 volts. So this is the short introduction of inverting comparator. So let's first see the uh, non-inverting comparator. So yeah, this is the theory of the circuit of the non-inverting comparator, where the reference voltage is connected to the inverting input, and the op-amp with the input signal is connected to the non-inverting input. So first of all is we assume that the two resistors is forming the potential divider network, and R1 is equal to R2 equal to R. So this is produce a fixed reference voltage, one for the one half of the supply voltage, and which is VCC by 2, while the input voltage is variable from the 0 to the supply voltage. And when the Vin here is greater than the VRF, the op-amp comparator output will saturate towards the positive VCC, and when the Vin is less than VRF, the op-amp comparator output is changes the state, saturate the negatively supply 0 volts, which is shown here. So yeah, this is the non-inverting comparator. For the zero crossing detector, this is the circuit of the zero crossing and the output of this. So the zero crossing is a voltage comparator which changes the output between the plus Vset and the minus Vset when the input crosses the zero reference voltage. So in a simple, the comparator is a basic op-amp used to compare the two voltages simultaneously, and it changes the output accordingly to comparison. So this is the zero crossing detector. Yeah, the fourth one, which is a time maker generator. So yeah, this is the output of the time maker, and in the input of the sine wave, the output of the zero crossing detector, being a square wave, is further passed through the RC series circuit if the time constant RC is very small compared to the period, so in of the input sine wave. So where the voltage across R of the RC circuit network called VR will be series of the positive and negative pulses. So yeah, this is the time maker circuit, where we in our output we get the spikes in the output waveform. And the last one is a sample and hold circuit, and where it creates the sample of the given samples of the voltage given to the input. After that, it holds these samples for the entire time The time during with the samples and hold it generates the sample of the input signal, which is called the sampling time. And the time duration of this circuit during which it holds the sampled value is called the holding time. So the main components which have the sample and hold circuit is involved the n channel enhancement type MOSFET. So yeah, this is the sample and hold circuit. So first of all, we start with the inverting comparator um circuit. So yeah, this is my inverting comparator where I applied the voltage sine wave input sine wave, and for the input voltage is 5 volts, and the frequency of this is 1k. My Vref is I applied 2.5 volts, and the voltage source for the VCC and VE I applied plus and minus 15 volts. So let's see the output of the inverting comparator. Yeah. Okay. So yeah. So in the output, yeah. So I applied input voltage, which is a 5 volts, and I get the output approximate 14.125 volts. So this is my output of the inverting comparator. So for the different frequencies of the of this, I uh, already make. So for the 50 hertz of the frequency, I applied the input of the 10 volts peak to peak, and my VRF is 2.5 volts. For the frequency of 50 hertz, I get the output of plus and minus 15 volts. Yeah, this is my waveforms of the other where I get the 50 hertz. For the frequency of my output is this. For the 500 hertz, this is my output, and this is the for the 1 kilohertz, and this for the 5 kilohertz and 10 kilohertz. So now I'm going to explain the circuit of non-inverting. Yeah, so where my input is given to the non-inverting terminal, and where I applied a sine wave where input is my 5 volts, and I given a 1 kilohertz frequency. My VF voltage is 2.5 volts, and I applied a VCC and VEE plus and minus 15 volts, and we check the output. Yeah, so for the non-inverting comparator, where I applied the input of the 5 volts, yeah, and I get the output which is approximately 14.09 volts. So yeah, this is the output of the non-inverting comparator. So after this, I already performed with the different frequencies for the 50 hertz and 500 hertz, 1 1k, 5k, and the 10 kilohertz. The last one. Yeah, so this is the circuit of the zero crossing detector where yeah, so this is my zero crossing detector circuit where I given the input to the inverting terminal. I given the input of the 5 volts, 100 hertz frequency, where my Vref is 0 volts here, and VCC VE is applied 15 volts. Yeah, so this is my output of the zero crossing detector. Yeah, so this is my output for the zero crossing detector. For the time maker generator, I performed the this circuit is also. Yeah, for the time maker circuit, I applied the VCC and VEE plus and minus 15 volts. I applied the input sine wave 5 volts input and 1 kilohertz frequency, and I used the precision. I used the diode here. My capacitor is zero point 0.1 micro, and R1 R2 value is 1K. So yeah, this is the output of this. I get the in output I get spikes. So yeah, this is the output of time maker's generator. For the last one, sample and hold circuit, this is my circuit of the sample and hold. My control pulse is in period of zero point 0.2 milliseconds and sampling period is zero point 0.1 milliseconds, where I applied the sine wave. Input is 1 volt and the frequency of the 1 kilohertz. So yeah, this is the circuit of the sample and hold. This is my output of this circuit, sample and hold, which I already performed this. So yeah, this is the output of the sample and hold, where I already written some applications for the zero crossing detector, which is used to check the conditions of the operational amplifier and also used for the frequency counter and switch purposes in the power electronic circuits. Yeah, thank you.